Hi. Welcome to the PLC channel. I will be happy if you subscribe to my channel. Step 7 software is used for configuration and programming in Siemens 300 and 400 series PLCs. In this video, I want to introduce you to the generalities and important windows of Step 7 software. You will get acquainted with 5 important windows in Step 7 software. These windows are Simatic Manager, Hardware Configuration, Programming, Symbol Editor, Simulation. First, I double-click on the Step 7 software icon. The Simatic Manager window opens. In this window, I click on New. I type a name for my new project. For example, PLC1. See the storage of this project on the computer hard drive here. In this window, I right-click on PLC1. Here we can choose the configuration and programming of Siemens 300 and 400 series PLC. First I select the 300 configuration. Then I click on the hardware. A new window called Hardware opens. First, I click on the Rack folder in the Catalog section. You will see a table with 11 rows appear. This is the rail on which the PLC modules are placed. I select slot number 1. Then in the Catalog section, I click on the PS or Power Supply folder. And I choose a 5 amp power supply. Now I select slot number 2. We click on the CPU folder and from there I select CPU number 314. I have to use slots 4 to 7 to insert the input and output modules. To insert the input module, after selecting slot number 4, I open the SM or Signal module folder and select the DI16 module from the DI or Digital Input folder. This module has the ability to connect to 16 inputs, such as 16 switches. To insert the output module, after selecting slot number 5, I open the SM or Signal module folder and select the DO16 module from the DO or Digital Output folder. This module has the ability to connect to 16 outputs, for example 16 lamps. That's enough for this video. Now I want to set the address of the input and output modules. I double-click on slot number 4. In the window that opens, you can change the address of the inputs. These addresses are okay and do not need to be changed. We have 16 inputs. We consider 2 bytes with address number 0 and 1 for these 16 inputs. I double-click on slot number 5 to set the output module address. In the window that opens, you can change the address of the outputs. First I uncheck System Default. And then I change the start number, which is 4, to 0. Now the first byte address of output is 0 and the second byte address is output number 1. This little configuration is over. I will explain the configuration in full in other videos. I return to the Simatic Manager window. Now I want to program. To do this, in the Simatic Manager window, open the folders to reach OB1. Double-click on OB1. And after clicking OK, the programming window will open. LAD, FBD and STL are 3 methods for programming in Step 7 software. On the left side of the programming window is Program Elements. Programming commands are categorized in each of the Program Elements folders. For example, in the Bit Logic folder, there are logical commands, and in the Counter folder, there are types of counters, and in the Timer folder, there are types of timers. For example, in LAD programming, I want to series 2 normally open contacts and connect them to a coil at the end. And above each input and output, I type the address. I type the first input I0.0, the second input I0.1 and the output Q0.0. To convert the program to 2 other forms, click on the View menu. To make the program easier to design and troubleshoot, I define a symbol for each of the input and output addresses. First, select the Symbol Table option from the Options menu. A new window called Symbol Editor appears. In the Symbol column, type the desired symbol, and in the Address column, type the input/output address. For example, the symbolic name of the input address I0.0 is A. The symbolic name of the input address I0.1 is B. The symbolic name of the output address Q0.0 is Y. Finally, I click on the Save icon and open the programming window again. As you can see, inputs and outputs have symbolic names in addition to addresses. With this icon, the place of the absolute and symbolic address can be changed. See these in LAD, STL and FBD. I want to test the program. First I click on the download icon. As you can see, an error message appears indicating that the PLC connection is disconnected. To fix the problem, I have to open the simulator window. I open the Simatic Manager. And there I click on the simulation icon. Now the simulation window opens, where the CPU module is located, which includes LEDs and run P keys, stop and memory reset. The digital input module consists of 8 bits, or 1 byte. The addresses are I0.0, I0.1 to I0.7, respectively, from right to left. The symbolic name I0.0 is the letter of A. The symbolic name of I0.1 is the letter of B. The digital output module consists of 8 bits, or 1 byte. The addresses are from right to left Q0.0, Q0.1 to Q0.7, respectively. The symbolic name Q0.0 is the letter of Y. After creating the simulation, I return to the programming window. First I save the program and then I download it. Now I click on the glasses or monitor. As you see, the program becomes colored. The part of the program that is green means that it is electrified, and the part that is a blue dotted line means that it is without electricity. The flashing green rectangle at the bottom of the screen indicates running. I open the simulator window at the same time. This window should be small so that you can see the simulation results and the program at the same time. In this program, we have two normal open contacts. First I check I0.0, then I check I0.1. You can see that the output is checked and this is the property of the AND gate. Note that the outputs should never be checked manually. The outputs themselves are checked according to the logic of the program and the status of the inputs. I simulate the same program in the form of STL and FBD. You will see that according to the logic of the AND gate, the output will only become 1 if both inputs become 1. If I want to parallel the inputs, I use open branch and closed branch, like this. In simulation, it is enough for at least one of the inputs to be 1 to output 1. And this logic is called the OR gate. See OR gate in 3 ways: LAD, STL and FBD. I will present another video to introduce the types of logic gates. In this video, you will get acquainted with 5 important Windows and Step 7 software. These windows are Simatic Manager, Hardware Configuration, Programming, Symbol Editor, Simulation. Goodbye. Do not forget to subscribe, like and comment.